3.Лекция.Либертариан-Партии.ру.
You see, indeed, but no two sunspot minima are really the same, isn't it? That is the problem. Science is about quantification. That's the kind of problem they have. And now I want to explain you. In fact, they say, oh, it's so simple. Solar irradiance, which is total solar irradiance, TSI, is just scaled as sunspot number, Sn, to the power of 0.5 or square root of that, or 0.7. I tell you, this is a big problem. You know what? When you set sunspot number, you go to 0. That's really a very easy math, isn't it, right? You don't need any complicated. You got 0. That won't work, actually, because you don't know the two minima. Let's say compare the 86 to the 96. They're not the same minima, really. One needs to know that. This is why immediately I would say that I would not use that curve at all for that reason. It's a flawed product. And then I want to show you evidence where you notice that the sunspot irradiance curve has a high in 20s, 30s, and 40s. And I want to explain to you, this topic, if you were to call yourself solar physicists, I mean, you know this kind of stuff. Except they've been hiding this systematically. By the way, all my work in sun irradiance estimate has been cited by IPCC positively in the second assessment in 96 and third assessment in 2001. And then I became one of the pariah because I spoke out. Then 2007, the fourth assessment and the fifth assessment, you can forget it. Sixth assessment, you can guarantee, right? You know, that no one will cite that work, right? No problem. I don't really care. It's them who's doing the problem. And this is basically science. What is it? It's about what your assumption is. The number one assumption is that I want to introduce you to this word, sunspot penumbra. I'll show you the picture in a minute. Because sunspot is quite complicated. Remember, we are dealing with 6,000 degree hot gas, something even warmer inside, 100,000 degree. It's boiling stuff. I mean, the magnetic field and the thing is rotating with all the stuff being plasma, so it's complicated. But they assume that all of this, something called the penumbra, would not be changing over time. That's basically what that sunspot number model says. But this is just to prove to you that other solar scientists beyond Wili Suna say that if this were to be their assumption, then they will be their estimate of the irradiance will be very wrong, isn't it, right? So, what is sunspot, right? By the way, outside there is the convection cell. But sunspot is actually a very giant entity. Some of the sunspot is much bigger than even the whole Earth you put it inside, okay? And sunspot come in so many varieties, but the simplest way to talk about this now is that in the center region, it's called the umbra, it's a very cool region. And then you got to think in terms of 3 dimensions. You're boiling from the bottom. Penumbra is actually the magnetic field that is being formed that is actually kind of slanted. Okay, that's basically roughly what it is. And then I want to show you some graph to show you evidence that you really have to be careful in this business. If you look at this estimate, by the way, this is the record from the Royal Greenwich Observatory because they have the daily image of the sun when it's not cloudy, right? So from 1876 until 1976 or so. And if you look at sunspot that has area that is larger than 100 units, by the way, the Earth area is about 169 units. So you can imagine anything bigger than the Earth, those sunspots that is big, you will see that it doesn't change much over sun if you measure this penumbra and the umbra ratio. Because we believe that this ratio will tell you something about the magnetic convection from the bottom of the sun. This is just an example to show you. In sunspot, in sun solar physics, we know. We have a whole bunch of story about how you classify this sunspot group. They are very complex. You can define up to 16 different distinct sunspot group, okay? And those things really matters because they have different physics origin. And then when you look at those small sunspots, something that less than 100 units, guess what you're beginning to see? You're beginning to see something interesting according to what I talk about, that I show you the irradiance curves, why I believe in that. You actually have clear evidence to show you that something changes on the multi-decadal time scale rather than those 11 years time scale that they keep talking about. So you can imagine, basically the reconstruction that the IPCC's favor assume that this thing won't change, but we show it definitively they change. So therefore, their result cannot be used at all even. Okay? The question now, why the other result is correct, I don't know the answer. But all I know is that it seems to be the best, the most powerful results that we can have for now. And this is the example to show you that indeed, why the irradiance curve was able to show that peak and come down and come up again. Okay? This is again showing you the sunspot that don't have any penumbra, which means when it's all umbra alone, the sun will be brighter in that sense. And then of course, it's also related to what I say, the convective velocity from the bottom, because you're boiling from the bottom. In terms of number, if you can change something of the order of 1%, 0.8%, you actually can have an equivalent of about 0.4% change in the irradiance. That's a lot actually. Because the IPCC say that it can only be 0.1%. That's a factor of 4. That's a very, very significant in terms of energetic. And then you can even see evidence in circular changes of the sun activity, basically the solar equatorial rotation. Okay? By the way, the sun is rotating very, very fast at the equator, 27 days or so. Yeah? And then it's slightly slower at the polar region, so it's differentially rotating, okay? About 40 days in high latitude region. This is another example just to show you that from 1850, we definitely can show that there is something changing on this multi-decadal time scale. Finally, very, very clear evidence to show that the sun rotated more rigidly around that time in 1930s and 1940. So in that sense, I'm rather confident in using the irradiance curve. I hope that actually essentially settled the score. The whole problem is still quantification, really, okay? But I have no doubt that the result there is reasonable. Now let's go to the final part, which is to show you how you find evidence of the sun in Canadian temperature record. So we already realized that during nighttime, you really don't want to study the sun effect, isn't it, right? Not that smart. And then, by the way, they always say that you want to study the CO2 effect during the nighttime. That's also not a very good idea, and I'll explain to you in a cartoon picture. It's basically related to meteorology. At night, this is what happened. You actually form an inversion layer that is very low, I would say less than 1,000 meters, right? At the bottom. So you essentially cut off your surface from the part of the atmosphere called the troposphere, right? You know, a few kilometers up. So it's warm there, you form this layer down. In fact, this whole idea, by the way, was borrowed from Professor John Christie, right, from University of Alabama, Huntsville. If you want to study the greenhouse effect, you want to study the impact of it all the way, because they call it the radiation heating down, right? You really want to study the CO2 effect during daytime. But during daytime, guess what the problem of CO2 is? You have to scratch your head, right? You have to compete with the sun. That's the problem. And I propose to you that if you want to find a signal of a Canadian sun effect in that, you better study the temperature maximum. Okay? And I'll show you the evidence quickly. This is just to, I shouldn't get into this meteorology, but to tell you that, you know, I study a lot about Alberta. In fact, I have a slide that I'll pass it on to use. Anybody want to study them, please use them. I studied the geology of the region, blah, 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 a lot of stuff. I've done my homework because I'm a good student. This is just an example, a visual part of the nighttime inversion layer you can see, right? Visually, you can even see that. And then the modern time is that we started to build, this is why nighttime temperature has been changing, by the way. But guess what? They always say, trying to say hint is related to CO2. Baloney, has nothing to do with it. It's just basically related to buildings, and then you are basically pushing your inversion layer further up, really, through basically roughness. You know, you changes the roughness of the surface, the wind, you just increase more vertical connection between the surface to the upper air. That's why the temperature minimum has been changing. That's true. Completely true. But it has nothing to do with CO2. Okay? So, again, we need to use the temperature maximum. First, I want to say that the sun really loves USA and Canada, as you can see. Here's evidence show you that if you use the temperature minimum, T minimum, this one, versus the sunspot irradiance estimate, not too good, okay? I wouldn't stand up there and say, yay, I found it, I'm so smart. It's actually the temperature maximum. It looks a lot more interesting. But I'm not here to talk about USA, obviously, but go Trump. I love the guy, he's good. Yeah, so we start with the small case. No test, by the way. What is the average temperature of Canada, right? Professor Madhav Khandekar, last year's speaker, he told a lot of some of us saying that he was surprised that Canada is very cold. Just kidding. He basically, by the way, that literature comes from David Suzuki Foundation. The mean temperature is about 5 degrees below 5 degrees Celsius, minus. But the most amazing fact is actually the Tmax. It's very near the freezing point, by the way, right? And that shows you that I really think that what I show you tonight is not just statistical correlation. It has some physical meaning, okay? That's basically the whole purpose. Again, go home at night. Please don't think about sunspot too much. Think about your wife. So first, we start with Canada. If you look at the temperature minimum, it doesn't look too good, really. Okay, yeah, but it's not about statistical correlation. Remember, no one has ever plotted this curve before, okay? You guys are the world premier, 450 of you. I'll get your name later. Here's the Tmax. I'm not claiming anything. I'm just telling you that the record can be seen. You can pull it out. No one has ever shown this, right? And then the question is still, so what? Canada it's really hard to average such a large region covering all kinds of geographical conditions, right? Can we see anything on the local and regional point of view? That's another very interesting consistency test. If you want to propose the sun as the plausible kind of agent for climate change, for example, or temperature change in this particular case, because it's a very specific thing. And then, of course, your great Canadian Environment Canada produced a report last year, a few weeks ago. It's called the Canada Changing Climate Report 2019. Again, April Fool's Day. I almost really thought it was an April Fool. And they stopped at 1948. Oh, they got that one really good, right? Oh, because there's not enough station. I mean, it's really, really subjective in that sense. Says who? Says you? No, I'm not going to trust you, right? Why don't you show the rest of the result, no? Because Canada, most of you know, if you guys know anything about Canadian, you all know the famous 1936 heat wave, right? They are really trying to avoid some inconvenient fact in that sense. This is a very interesting image, by the way, completely generated by a computer being trained to paint like Van Gogh, Yeah, so for regional details, we got to look at Tmax. This is for Alberta, right? Not too bad, but it's there. It's something, okay? It's not the kind that you've never seen before. Calgary. Surely there are stuff that don't match up, but it's there. Oh, Edmonton. It's also, I would say it's okay, it's there. I'm not making any claim, by the way. I only want you to say that it's not too difficult to show this thing. It's there. What is so hard about plotting two curves, right? Except is that it takes me a long time to get this insight. It's the Tmax that is important. Yes, I love Alberta, definitely. Yeah, so what? I'm trying to impress you about here. But there are many more stuff. Actually, I stopped playing with this game, but the whole point is that there are stuff everywhere, right? Winnipeg. Hey? Well, I started to say that. Vancouver. Oh, don't tell David Suzuki. This is not so good, by the way. The sun don't like them too much. I blame it on the sun every single day. But really, so what, right? I told you it's all about understanding. It doesn't matter really. It's about understanding. Is it true? Okay? Is there a meteorological perspective or explanation to this? I think the simplest way to explain this, again, I'm always the kind of guy who wants to find the simplest way to explain and then don't add any complexity, then you add on, whatever you need. The most simple way to understand this is basically pointed by a graph like this. You basically got a two low pressure system, right? In the Gulf of Alaska and then, of course, Bermuda region, which is typically high. And then you are basically drawing air from the south, warm advection, really, right? During the warm period, the warm phase of that decadal phase. And then for the cold phase is the opposite. You got a high pressure region from those regions, you draw the cold air from the north. I'm focusing more on your Alberta region, right? Not too bad. Something is there. Okay? Yes, fundamentally it's the problem, right? Because they could not tax the sun, basically, what it is. And then later they're going to tell you that we're going to try to go to the sun at night, okay? Midnight. Yeah, it's true. I like this quote a lot. It's because after so many study and in-depth research project by all the top minds in this climate catastrophe study, It was determined that there's just no way to tax the sun, so the sun is completely ruled out. Yes, it must be. We must tax carbon dioxide. Really mad. 3 more slides is going to be the end, because you will, I know everyone, so I want to stop you from asking that question. I don't know really. But the question, people say, what's next? What's the next 100 years? That kind of thing. But I'll show you the result. Because I'm the first one with my great colleagues. Actually, I'm only playing an assistant role, you know. Those guys are the good guys, all my friends. This is just to show you the irradiance. The top one is clearly June. The bottom most is December. In Alberta latitude, 51 degree, Calgary. We're talking about 400 watts. Remember, doubling of CO2, you guys know the number, right? Professional engineer. 4 watt, roughly, right? Really hard to find this effect, okay? And now I'm going to blow up this tiny little thing. The whole way the climate system works is you never ever subtract the seasonal cycle out. It's the whole season evolving, okay? Warm, cold, but it's doing that kind of thing. This is the plot of the 1,000 years of history of the sunlight estimate. And this one including the effect of the orbital forcing, which means you account for all the different planets affecting the sun-earth geometry. You have the moon in it. You also have the total irradiance intrinsically changed by the sun. So you put all the factors in. This is actually the first time ever produced. This paper has already been published in 2017. No one has ever read it yet except myself and my co-author. I hope some of you read it, you know, for God's sake, we did that work. But what I'm showing you is that you have to be careful with your season. The top one, let's say your top left, right, is MAM, stand for March, April, and May, spring. June, July, August, summer. And then autumn, September, October, November, and then December, January, and February. The two most key seasons for high latitude region is obviously the summer and the spring. The spring is doing different things. The spring season has been systematically warming up actually over the last 1,000 years or so. And then the summer one has been cooling. This is the famous Milankovitch that's saying Ice Age is coming, because Milankovitch only consider the summer stuff, right? Because you can always build ice. It's always cold enough to make ice in the winter, and fall time. Its worry is actually about when the summer melt is going to go away. So can you build your ice sheets, right? If you worry about ice sheets problem. But I'm trying to point to you that if you know numbers, science is all about numbers. Those amplitudes are very big numbers, okay? This is actually for your latitude, right? For Calgary. And now the final graph is to zoom in on the next 100 years. What I plot is then from 1900 to 2100. This is for all 4 seasons. And you notice that for the next, 2050, 2060, 2040, roughly. This is actually now a challenge, right? That the irradiance, we know the irradiance is going to go down. At least the sun energy coming in. I'll leave it at that because it's going to take a lot more interesting way to try to explain directly how it's going to change the climate on Alberta and places like that, right? But at least that, by the way, this is what we call the boundary condition. This is the stuff that is actually was claimed to be solved for a very long time by a lot of these King Kong people. You know, I call them King Kong people because they do their term showing their hairy chest. But they haven't done the calculation. They haven't even got the moon in it. They haven't got a lot of things in it that I kind of scratching my head. But I thank them. I really thank them for giving me the opportunities and my colleagues for us to produce this orbital solution plus the irradiance estimate to plot this curve and publish the paper in Earth Science Review for the first time. And you know, we have all the stuff. I haven't done, because science is not about promotion, but I have to tell people now, so a lot of these climate modelers should start using this, right? And perhaps we can move forward from then, okay? I think with that, I'll just stop, let you guys ask some questions. Thank you.